The speakers this morning, I really appreciated their message and their presentations. And Zach, you were an awesome victim this morning. But when they talked about the things that it takes to keep a product in good quality and the fact that grain never gets better once you put it in a bin. It's the best quality it's ever going to be right out of the field. Only two things can happen when we put it in storage, and one is that it stays the same. That's the best we can hope for. The other is it goes downhill, and we saw some really wicked pictures this morning. I really enjoyed seeing those pictures. Or I didn't enjoy seeing those pictures, whichever way you want to look at it. Those were kind of tragic, especially the one where we had the river that had gotten 3 feet into the bin. So things like that happen to us. But in integrated pest management, that's not just fumigation. We're going to talk about the piece that fumigation plays with that. But it includes all of our management. We think about pests as being the demons, and they are. Where grain, its role in life is to spoil for us. Somebody said that this morning. I like that. Insects, their goal in life is to survive and eat our grain. So we need to be able to handle that, a piece of that. But so is aeration, and so is how we put it in the bin, and so is the quality of the grain going into the bin. All of those things work together for integrated pest management. So let's get started with our whoops. A word about phosphine. Phosphine's the most dangerous chemical we can purchase in the agricultural field. It takes 200 parts per million for 100 hours to kill all the life stages of insects. What is our limit of breathing phosphine without mask? 0.3. It takes 0.3 parts per million to kill you. They're a lot tougher than we are. So this gas that looks better. This gas that we're certified to purchase, this isn't funny stuff that we're working with, and that's why you have to have that certification. Okay, let's see if this goes now. That's all right. 77%, I'm going to turn this way because I need to see it too as we go through this, but 77% of our grain bin accidents happen when we're unloading bins. The message this morning was just excellent and was right on target with some of Purdue's information that Bill Fields sends out about our number of accidents, and of course we all think back to the 2009-10 year when we didn't have anything dry to go into the bins, particularly in the Midwest. But 77% of those bin accidents that happened, even in that year, were when we were moving grain, and it happened because it was out of condition grain. So, but in the fumigate area, and this is kudos to our industry, most of the accidents that happen with fumigates are not in the ag industry. If we look at the list in the past, say, 10 years of deaths due to phosphine poisoning, it wasn't us that did it. Okay. In the case of the 2 girls in Utah, the little girls that were killed, that was a soil fumigant that was misapplied. Perhaps an employee sneaks a few tablets that were left over, throws it under his house at home to get rid of the spiders and the skunks, and kills his children. That's not our facilities doing that. But we're going to be the ones that feel the pressure from the government because of that, because what Washington, D.C. hears when they think phosphine is that phosphine kills little girls. So we have to be real careful with that. But kudos to us. We've been doing a good job. Our training that's set forth by the government and the laws, it's working. We have to be certified. We have to have CEUs. We understand how deadly this stuff is. So I think we do a pretty good job with that. Yeah, front is back and back is front on this thing. Okay, that's all right. So when we're unloading grain and it's out of condition, and some of this is a repeat from what we went over this morning, things happen and the grain won't go down in the reclaim system. And we saw pictures this morning, the main 3 ways. Flowing grain, somebody goes into the bin to fix a stoppage for some reason, the auger's still running, nothing's coming out the auger, off the belt. Somebody goes in to break it loose. They get caught down in the flowing grain. As children, we played in grain bins with the auger running. I did. All of us that were raised on a farm, that was a fun thing to do during harvest, go play in the grain bin. We can't do that anymore because we handle grain so much faster. Everything's so much larger. We don't have time to save ourselves if you start to feel yourself going down into the grain. Of course, the collapse of a grain bridge, that happens when you've got out-of-condition grain and it's made a shelf. Somebody goes in to break that shelf, they fall through. That's about 99% fatal. And then the avalanche or the vertical grain wall falling down over someone. Two things happen there. You've got out-of-condition grain, and somebody went into the bin and violated OSHA standards because they're working down below the top level of the grain. So things we need to remember about that. It can happen in a grain bin, but it can also happen in a gravity wagon. We almost lost a child in Oklahoma. Jumped over a gravity wagon, got pulled down into it. Dad didn't miss him for a little while. We start seeing a little leg coming out the bottom. We're able to rescue him. But it can happen even in our handling equipment. It takes 4 to 5 seconds to be trapped, 20 seconds to be buried. So 1, 2, 3, 4. You can't get yourself out right now. It's just that fast. So that can be attributed to the fact that our augers are so much bigger, we handle things so much faster. The bins are larger, you've got higher static pressure. We can't let our guard down on this, and we need to tell our employees about how fast this can happen. There's a lot of good demonstrations and videos out on the web about this kind of thing too. So a lot of good training material just needs to be used. If the grain's in good condition, our reclaim systems do what they're supposed to. We don't have to go in the bins. There's some states now, some companies that have no entry rules on their bins. I think that's good, but somebody eventually is going to have to go in the bin, or they'll choose to go into the bin even if it's against company policy. So that's when the accidents happen. We don't want to wait until everything's locked out and tagged out, or the conditions are just right. Somebody's in a hurry. I see reports someone fell into the grain bin. I have yet to almost fall in a grain bin, but I know it must happen because that's what's always reported. And sometimes I think any attorneys in the room? Oh, that's good. Okay. Any OSHA people in the room? I need to survey my audience here. That sometimes the attorneys will report things like that because it plays out better down the road for some situations. But if our grain's in good quality, then there's no reason to enter that bin, or there's little reason to enter the bin. The grain's flowing, it's going out the reclaim system, it's doing everything it needs to do. If we're not in the bin, accidents don't happen. Incidents. If you're in the insurance company, it's incidents. I'm learning that, right, Brian? So why do fumigators have to enter the bins? It's usually not the fumigation that it's not your job to go in and clear these things that happen in the bins. But as fumigators, you do have to enter on occasion. Sometimes it's required for a treatment, for tarping, probing in the product. There's several reasons you might go in the bin. I'll show some pictures in a minute that kind of make me shudder, but they bring home a good point. Maintenance and cleaning of the facilities. Sometimes, especially contractors, are called in to do this kind of work, get the bin ready, then put the product in and come back and fumigate it. So there's a reason there to go in bins also. If you're called in to clean out a bin, what's that tell you about that bin? The company didn't want to do it themselves. What do you think's in the bottom of that bin? It's old, moldy stuff. It's not going to be a good day if a contractor's called in to clean out a bin. So just know if you're a contractor and you get a call for that, be prepared with some of your safety things. Preparing and sealing of bins. Perhaps they're installing a closed-loop system. Extra permanent sealing has to be put into that structure. So another reason to go into a bin, so that bad things can happen. Anytime you go into a bin, whether it's got a lot of grain in it or not, some bad things can happen. You need to be prepared. Hazardous atmospheres, oxygen deficiencies, dust contamination, flammable gas vapors. Sources come from the spoilage, the empty bin. The owner says, yeah, my bin's empty. You look in there, and there's big clumps of rotting grain all in the bottom. We lost an individual in Oklahoma in a boot pit. Wasn't even harvest time. Wasn't even fumigation time, but there was CO2, enriched CO2 down in the bottom of the boot pit, and we lost this individual. Didn't use his gas monitors. gas monitors and whether they're single gas or multi-gas monitors are so important in your operation. We have elevators that are still using the glass tubes. Glass tubes will not save you. It takes too long to pull the gas up into them. So investment in a good gas meter is just critical. And, of course, grain dust. We're not going to talk about explosion in this presentation, but that's certainly something that we got to keep in mind, and we can talk about that on another day. Mold, just because you can't smell it doesn't mean it's not there. Something if you see some moldy grain, then there's spores in the atmosphere. So masks, they're important. And fumigants. If it's been fumigated, whoever did it may not have been able to clear out that fumigant completely. There was a situation where on a dry year, which we had 3 of them down the southern part of the country, drought, it was so dry that our phosphine wasn't gassing out in the grain. I thought it did, but we went to unload that bin, and all of a sudden the personal monitors start going off, and it hadn't been under fumigation for a couple of months. But it was so dry that year that the phosphine tablets had not gassed out until we went to move that product. So even though it's been cleared, the monitors up at the top said it was okay, that the fumigation was over, we still had a problem. So something to watch for. This is what you don't want to see. The pictures from this morning were so much better than these pictures. I hate to show these, but these are just some examples of what you don't want to see. Of course, the stuck to the steel bin wall over there on the side. We've got some stalagmites in the middle. Those were drips of condensation off of a roof. The picture up at the top right, that was spontaneous combustion of some soybeans. And then down at the lower right, that's a drip off a temperature cable in the middle of that bin. So you kind of get in the picture here that water's not our friend. Every one of those pictures happened because of excess water someplace. So those are the things that as a fumigator, you're going to go in and look for these things. What does water mean if you're going to use phosphine? Where's my fumigators? Fire. Fire explosion. So if you see something like this, first of all, you're going to know you've probably got insects. Okay, we'll talk about those conditions in a little bit. But it also means there's water. There's free water someplace. And that you need to ascertain for yourself that you're not going to have a fire or an explosion when you start to apply your product. What to look for? Poor grain quality going into the bin. If you're a contractor for a company, one of the questions that you need to ask is what condition was that product when it went in the bin? Now, this is not on your list of questions to ask, but wouldn't it be important to you to know that they put up 14% wheat or wet corn that didn't get dried well? The 2009-2010 year, we assumed all of it was wet, but that's not the norm. As a fumigator, you need to know what that condition was going into the bin because it didn't get any better. And the wetter it is, the worse it got. As a fumigator, you need to know that information. Differences in temperature inside and outside of the bin, that's where we get our really bad condensation problems. The graphics from this morning were really good about tables developing inside the grain bulk. That happens, obviously, whenever you put 2 temperatures that are different together. If you have a 15-degree temperature differential, you're going to have condensation. Now, how much depends on the relative humidity in the air. But 15 degrees difference will give you some condensation. And so that's something you need to be aware of. Is this bin, is it shaded on one side? Are there other bins on the side where when the sun comes up, that bin's hot on one side and cool on the other? That's a sure sign for condensation. So these temperature differences are something you want to look for. If you're going to fumigate a bin and there's a big cold front coming through, might want to wait a day or two because there'll be a big temperature swing during your fumigation. I like this graphic. I've used, I think it came from Purdue a long time ago, but it really shows the different things that can be present that causes our grain to go out of condition. When it goes out of condition, The insects love it even better. So let's look at some of these. We start up here in the top right with large temperature fronts. I don't know about you all up here in Nebraska and Iowa, northern part of the country, but in Oklahoma we can have a 50-degree temperature swing during a day. That's not unusual. Talk about some challenges in storing grain. Fortunately, the wheat's usually pretty dry. So we get condensation coming off the roofs, especially if you don't have enough air vent space. The exhaust fans need to be sized properly. Your passive vents need to be sized properly. And the larger the bin, the harder that is to do. Some of our old adages of how we size our exhaust systems and our passive vents, I don't think are adequate for our 105 and bigger bins. I'm seeing a lot of problems even on new bins with condensation because we don't have enough airspace to move that condensation in the headspace out. So something to think about if you're putting up a new bin or if you're having problems with the bin you have. Putting in different moisture content product in the same bin. This morning we had a good graphic of cool grain with hot grain going in on top of it. Different moisture contents will do some of the same damage, not as intensely as what temperature difference does. But you want to watch that. Overdrying, shrink, fine material, the seeds or the kernels break. Where does the fine material go to? Goes to the center. That's where your problems start. And sometimes you don't even know you got a problem until it's too late. Down here in the bottom we have insects. Now something about insects that's kind of curious. When we're comfortable, they're comfortable. So that tells you that someplace between 65 and about 95 degrees temperature, they're happy. And they like kind of moist conditions. Some of the insects, the wetter the condition is, the more they will procreate. Some of the insects won't live there if it's too wet, and some of them won't live there if it's too dry. So knowing your insects is really important to know that they can tell you a little bit about what the conditions in your bin. This crust and spoilage picture down here in the bottom, we know to look for crust and spoilage, but I like the little nose with the clothespin. You have the best sensor in the world right there on your face. Everyone in this room knows what good grain's supposed to smell like, right? And if you get a whiff of something that's not good grain, there's a problem. And you need to know what it is, especially before you enter the bin. But that's going to taste just like CO2. You can detect it really early just by smelling through the access. Hot spots, that's something that happens with certain kinds of grain, particularly handling canola. Some of the oil seeds will continue to respire after they come out of the field for as much as a month to 6 weeks. And that's just an organic thing that happens, biological. But those hot spots can get up to 130 degrees if they're not broken up or if aeration doesn't remove that heat. The insects will start to set up around those hot spots, nice cozy atmosphere, and then the insect population just blossoms, and then you've really got some big problems. And then moisture migration happens anytime you've got that 15-degree difference. So those are all things that, if you'll look at that, there's two things you've got to manage, moisture and temperature. So that tells you moving the grain if you don't have aeration. Sometimes even with aeration on a concrete, you've got to move it. But you've got to manage your aeration systems, and you've got to watch for places in your bin where moisture can either get in or form in the form of condensation. What the insects are looking for, they look for wet spots. Some of the insects will not be in a bin if the product's under 13% moisture content. Some of them don't like it to be really wet. They like wet better than they do dry, and that's one of the reasons we put grain up a little bit drier. But the insects are looking for leaky structures. Aeration systems that are not properly designed. I would really like to think everybody out there knows how to manage their aeration system based on EMC and ERH. How many of us even know what that stands for? I'm preaching to the choir. I'm sure everybody here does. But as I go out to do elevator visits around our state, I might as well be talking Chinese. Those principles aren't known to just everyone, and not everybody's got an automatic controller. So knowing how to manage those aeration systems right is just key. the rules of EMC and ERH and where they match up and when to run that aeration system is your Bible. And that's key to making aeration work for you instead of doing more damage. Also, how many motors and fans in your facilities still have the nameplate on them? Okay, I went out to a facility last week, and they had a flat storage. Some fans had gone bad. So they pulled the fan. This is a flat storage, 250,000 bushel. They pulled the fans off their 120-foot tall concrete and put it on their flat storage. Well, we've got a difference in static pressure of material that might have been 30-foot tall in the flat storage compared to 120-foot tall in the concrete. That's not the same fan system there, okay? And they couldn't tell me what that fan was rated at because the plate was missing and who knows how old it was. So just knowing information about your fan system is vitally important. A fan that works on wheat doesn't necessarily work on corn. Actually, it would probably make more sense the other way around. Corn has lower static pressure because there's more void space between the seeds. So if you're using that same fan for wheat or barley or oats, it's not going to have the same pressure, okay? If you turn around and use that on canola, it's not going to work at all because canola has 4 times what corn does of static pressure. So designing that aeration system, there's a whole art to that, and if it's a flat storage, it's even more of an art. So good contractor. Temperature cable malfunctions. If your temperature cable continues to read 256 degrees all the time, what happens to it? What's wrong with it? It's not working. 256 is a key electronic term. That's an electrical geek term of it's saturating the circuit board. I doubt if it's 256 degrees all the time in your bin. Now, if it's reading 180 one time, 120 the next reading, it was reading 50 and all of a sudden it's reading 110, that cable's doing what it's supposed to. It's telling you there's a problem in that bin. You've got a hot spot. If you don't fix it, we're going to have a big problem, and it will be not only a bad profit situation for you, but an unsafe situation also. So 256, that's kind of what you're going to look for a malfunctioning cable. If it's in the headspace and it's 100 degrees outside and it's reading 50, it's probably not working right either. So we kind of use some common sense about that. Temperature cables, I am just a firm believer in them. Those are your insurance. That doesn't mean you read it once a month. It's not going to give you the information you need. It needs to be monitored weekly. You invested in it, so use it. It's really nice when the computer keeps up with it, but that's not always the case. We talked about that. 65 to 95 insects are pretty comfortable. They do not reproduce under 60 degrees, and they don't do any damage to you or reproduce at all. Many of them die at 40 degrees. Southern part of the country, we can't get grain down to 40 degrees, but we can get down to 60 degrees and manage that. We can manage insects without fumigation. That can be done, but you've got to be able to manage your aeration systems properly. Do you know your insects? Oftentimes they will tell you what's wrong with your grain. If you're trying to store 11% wheat and some of these insects, you're getting them in your traps or you notice them when you look in through the access ports, if they're there, there's a moisture problem because they won't be where they're uncomfortable. The insects that like moisture over 13% and they're in your wheat crop is supposed to be 10 or 11%, at the most 12%, you've got some moisture problems in there someplace because they're happy. They won't be where they're uncomfortable. So you can many times determine what's wrong with your grain just by detecting what kind of insects you have. Traps are really important. If you go up to a bin and there's some poor sanitation practices, if you're an OSHA inspector and they drive up to your facility and we've got weeds that are 10 foot tall around the bin, there's loose grain on the driveway, what kind of impression does that make? Not a good one. He knows right off that this is low-hanging fruit. And the same thing happens if you're an insect, okay? They see grain on the outside of a bin, oh man, that's home, especially before it freezes. And their next step is right into your bin. So these are the things that you want to look for. Poor sanitation procedures, your reclaim system's not working, malfunctions, inadequate dust management. You know, this is probably before the end of the day, if you haven't already got this pictured, this is a system. Fumigation's a part of it. Good quality grain's a part of it. Aeration's a part of it. All of this works together. Sanitation on the outside of your bin is just as important as sanitation on the inside of your bin, because you've issued an invitation to insects and rodents and birds on the outside of your bin, and their next step is right inside your bin. So all of this works in a big system. You might as well make it work for you also. Fumigation management plan, by law, every facility has to have one. It's a discussion point whether it has to be rewritten every time you fumigate. I do some consulting on the side besides Oklahoma State University, and I've been on a couple of cases where this was the question, if that fumigation management plan had to be rewritten every time that bin is fumigated. And the answer is no, it doesn't, but it has to be updated, it has to be reviewed and signed off again. So keep that thing handy, and as a fumigator, you have to look at it every time. That's the law. Inspect the facility for any changes. Were there any bolts that were missing? Did they add something to it? Has it got a loose door? All those things need to be noted. Document, document, document. Any water leaks? Any potential water leaks? These are things that the fumigator needs to know as well. This is not only a quality issue, it's a safety issue as well. So things that could save your life. It could also make the difference between a good fumigation and a bad fumigation. As a contract fumigator, you're paid to come in and get rid of insects. And, you know, if you create a bigger problem than what they had before you came, you're not going to be in business very long. How well, in some of our larger bins, the access is not as good as we'd like. Perhaps the product wasn't loaded with phosphine, with tablets into it. How are you going to distribute those pellets? You don't want them to stack. On my fumigators, what's the maximum concentration before an explosion happens? 18,000 parts per million. Now, it's really hard to get that kind of concentration outside of the flask. Have you ever had one flash? That's pretty exciting, isn't it? Yeah. Because you got up to over 18,000 parts per million in the flask before it was opened. But sometimes it is possible for a pile of phosphine. Technically, it's possible for those to explode or catch on fire. Now, very rarely happens, and if you try to make it happen, you just about can't get it to do it. But there is that possibility. So if you're distributing pellets on the top of a large diameter bin and you're doing it from one spot, you've really got to be careful to get those spread around. They're going to go down the angle of repose if you haven't leveled out the top of that bin, and congregate around the edge. So it's a possibility, something that you need to just keep in mind. How we keep yourself and your workers safe during fumigation. Following the rules is your first step, but use common sense. Every bin is different. Not far from where we farm, there were 2 concretes that were put up at the same time by the same company, by the same contractor. I don't know why they're different, but they are. As an industry, we've never really standardized on any one facility. So every one of them has the personality. And that's the advantage to having a licensed fumigator on your staff or in your worker group, because they know that bin or those bins. And nobody else knows it like you do. So use some common sense. And safety is where it's going to really pay off. If you've got your office right next to one of your bins, you've got to make sure that the fumigant doesn't go over there. And that can happen even through tunnels underneath that particular facility. So just got to monitor and got to know where things are going to go in your facility. Preparation, cleanliness, bring that up again. Cleanliness is part of your IPM plan, part of integrated pest management. It's not just so it looks good. Anything that's left over from the last load is an open invitation for insects, and you're starting in the negative on the next load if you haven't cleaned that out. So you're in the red before you ever get started as far as insects go. You got to get in and clean that out. Now, if you're handling certified seed, it'll really be important that you get in and clean that out, just from a product viability standpoint. But from safety and insect monitoring, cleanliness is just next to insectlessness. Hard to do. It's expensive to do. If you've got a false floor or a perforated floor, dang hard to get under there. But clean the best you can. Empty bin treatments. Know if the grain's been treated. We'll talk a little bit about empty bin treatments in a minute. There's a new resource for what chemical can be used for that. We just came out with this resource. There's the address on the web. I didn't bring copies because you guys can read it online. Mark, would you pull up Safari for me? This is a fact sheet that we've got out on the web. The nice part about this fact sheet, if you'll read the first page or two, it's pretty good reading. But the second, third, and fourth page has a really good, now scroll down a little ways, has a really good summary that Edmund Bonjour, one of our entomologists, put together. And this summary is about the chemicals that are available for empty bin sprays, empty bin dry treatments. Keep going. Get down to the tables. The engineer wrote the first part, so, that part puts you to sleep. But get down here to these tables. What products are available, what the application is, and how they work. So it's just a handy reference for your empty bin treatments, your perimeter sprays, your perimeter treatments. Some of these products are more available in certain areas than others, but they're all listed for this application. So go out to that website and or send me an email, and I'll send you a copy of that. But it's a good reference to have on hand about empty bin treatments in preparation for the next load of grain. Okay, back to PowerPoint. And that's where we were. All right, let's get into some of the legalities. Entry bin permits. Before you go into a bin for anything, including fumigation, entry bin permit is required, written and kept on file. I'm sure if you're a safety coordinator, you know these rules by heart. But all a bin entry permit is a checklist. It's your flight checklist for going into a bin. It reminds you of the things you need to do. Has to be on file. It's required by OSHA. You don't have to have one legally if the employer or a representative of that company is present during the entire operation. How many times is that going to be the case? So a little glitch in the law there, but permit's not required if those things are in place. My advice is get an empty bin permit, then you don't have to worry about it. Okay? If he decides to go to lunch during your fumigation, then you're still covered. What's a confined space? There's been some discussion throughout the United States about what is considered a confined space and what isn't. OSHA tells us what a confined space is. Some say that 1910.146 doesn't apply to grain storage structures, but if you get inspected, 9 times out of 10 they're going to say it does. 1910.272 is our Bible, and it talks about some of these things. And if you're a safety coordinator, that's the one you need to know by heart, is 272. The things that's considered in confined space is the size and shape that allows a person to enter and work. It has a limited or restricted opening for entry and exit, not designed for continuous human occupancy, which is always the case in our bins. And then 146, it has some criteria in that. It covers these other 3 also. So if you have a question of whether it's a permit-required confined space, if you don't know for sure, then get the permit. That way you live on the safe side. Here's some of the other criteria that's in 146, the hazardous atmosphere, potential to engulf. So anything over 4 foot, grain over 4 foot is considered to be an engulfment opportunity. Has inwardly converging walls or a floor that slopes downwards, so any of your cone bottom bins would be in this category. And other characteristic recognized as a serious safety or a health hazard, such as a mechanical hazard. And that's where OSHA just goes wild with the interpretation. It's kind of like the reasonable thing in the presentation this morning. That's when your inspector can make some different determinations on confined space and permit-required confined space. If you've got a question, just consider it a confined space and get the permit. Next thing you're going to do is notify the LEAs, the local emergency agencies. As I go around the country, particularly working with consultants and with the law firms and all, this is where I'm seeing some things not done right. They didn't let the fire department or whatever agencies close by, the sheriff's department, police department, know, or their fire department is a volunteer fire department and nobody lives there, nobody's there most of the time, so they just taped a sticky note to the door. Well, in Oklahoma, I can tell you what happens to the sticky note on the door. It's not there very long. It's blown on up to Kansas and farther north. So how that's done, it needs to be handed to a person that recognizes the fact that you delivered the notice that you're fumigating that day to them. So something to keep in mind. Written notification's best, hand-delivered's best, and write down who you delivered it to. Again, document. If OSHA shows up and you don't have a document for it, it didn't happen. The whole company can say something happened. If you don't have it written down, in their eyes, it didn't happen. So write down what it is you did. De-energize, lockout, tag out, that's a common practice that we know has to be done. But as I read some of the news press on incidents that happen, lockout, tag out didn't happen. And it's just got to. Don't go in an energized bin. Use your proper equipment. If you go into a bin, bin entry kit's required. You need a harness on. Has to go to an anchor point. Lifeline goes out the door. OSHA doesn't tell us what to do with that lifeline, but it's pretty apparent. It needs to be tied off to something. Can't be any slack that will let you fall more than 2 foot. So that's required by law, and it's just a really, really good idea anyway. Test your air quality. Monitor. Never, ever work alone. Ever, ever. That, again, is a OSHA law. But still a good idea. Have a partner on the outside of the bin that's in contact with you and can go for help if something happens. This is just a repeat of that. You may have a boatswain's chair along with your harness. But as a fumigator, you get into all kinds of weird situations. Just know that you've got to have the PPE on, and it's got to have a lifeline. As a fumigator, you need to know these standards on all your different gases, particularly phosphine, if that's what you're treating with. Phosphine and oxygen. If I had to just pick 2 gases, those are the 2 I would pick. The third one would be CO2. Then you can go from there depending on your situation. But those are the ones that you need to be most familiar with. Bump testing. Everyone in here is going to raise their hand when I ask this question. Every time you use your monitor, do you bump test? Sure you do. Okay, I could ask that in Oklahoma, and I probably wouldn't get. Yes, sir, Zach. Sure. That one? Okay. Bump testing, that means that you've got a setup where you can give that sensor a little bit of a test and see how it reacts. That's kind of the simplified version of it. It's not a calibration. Calibration is different. That's a whole different setup, and it has to respond accurately to a certain amount of gas. A bump test just tells me, yeah, this equipment's going to respond when it sees phosphine or whatever gas you're testing for. It's required by law, and that needs to be documented. So if you're not doing that, you're in violation. If you're doing it and not recording it, you're in violation. Okay? Did that do it, Zach? Okay. Well, I think this is what I said. Brian says I'm running out of time. So it's compared to the actual quantity of the gas that's present. Your instruction manual tells you how to do all this. Again, it's required by law. Full calibration is generally done by the company. OSHA says every 30 to 60 days. That's not practical. They will approve whatever is in the manufacturer's instructions. But you need to be sure that you've documented that you followed manufacturer's instructions on calibration. And that's usually sending it back to the company. If you have enough monitors and you're using them that often, you can actually buy calibration kits for your company. A little pricey, but it's cheaper and more convenient than sending it back all the time. Plus, you've got your equipment there with you. It's not in the mail. If your equipment fails a bump test, then it has to go back for calibration. You have no other choice. When to bump test, these are the regulations on it, and that's also covered in your manufacturer's instructions. You know, when we fumigate, it's important that we follow the label on the fumigant. It's also important that you follow the label or the instructions for your monitoring equipment also. If you go to court over something, that's one thing they're going to ask you about. If you can't show you did it, you might as well write the check. Here's some opportunities to buy the calibration kits. If you'll go out and Google, you'll find lots of lists. If you visit the vendor hall, you'll see some more opportunities also. Buy Cal Gas, that's where you can get some of the gas to test with. Anybody use anything but phosphine in here? Methyl bromide? Chlorpicrin? Anybody still using chlorpicrin? So we're mostly phosphine users. It's the cheapest. It's the easiest to apply. It still works on most insects. California has lesser grain borer that are resistant now, though. So resistance is something we've got to work for. As fumigation experts, we have to do a good job when we fumigate. We can't just hit and go. You get rid of the adults, but their eggs, their larvae are still there. 4 days at 100 or 200 parts per million, 100 hours for 200 parts per million gets really close to getting all the life stages. These, as fumigation experts, you're going to know this is how fumigant comes. There's your procedures. These are the pictures I don't like to show because we've got people in those bins. It's over 4 foot deep, and what's missing? Harness. Yeah, you guys got it. I feel good. Besides pellets, there's some of your other products that are available. You don't have the residue left in the product. It's important. The cylinderized gas is becoming more prevalent, especially in the rail car industry. You have immediate concentration. Doesn't take time for it to gas out. But there's some extra equipment that goes with that in training. So go through those. There's a generator. If you've never seen a phosphine generator, it's what it looks like. Summary. Use this product. Use the product. Choosing the products, choose the one that's economical and safe for you and your situation. That's important. Train your people. You're going to hear training today and tomorrow over and over and over. Document everything. When we control our insects, you're going to keep the grain in better condition, and when we have good condition grain, it's safer. That's the equation to remember. Makes you money also, but it helps you not spend money on lawsuits as well. So, with that, time for a question. Couple of minutes for questions. Joe.
Dr. Cook, thank you, first of all.
Thank you.
I just have one quick question. What do you see as the number one cause of oxygen deficiency?
It's been displaced by some other gas, CO2 or methane. Okay. Rotting grain. Now, some monitors, this is kind of interesting. If you can find a monitor that has a CO2 sensor in it and it's less than $500, you need to ask a question whether that's CO2. They come standard with CO, carbon monoxide. And if you don't have a combustion engine around someplace close, you're not going to have carbon monoxide in a grain bin. But you will have CO2. CO2 sensors are more expensive, and a lot of times you have to ask for them. So when you see a cheap monitor out there, 5 gas for 4 gas monitors, and it's not very expensive, that's the difference, is that CO and CO2 sensor. Good question. Thanks, Joe. Other questions or comments? I learned from you all, too. I'm going to learn way more than you guys do. Jeff? The forklift. I'm sorry, 4-foot reference. OSHA says that anything over 4 foot deep, there is a potential for engulfment. So that's the reference there. They also say that if you're going to be 4 foot off the ground, you need a harness. How many light bulb changes do you make without a harness? Okay. But that's the law. Other questions? Safety directors, you got to know all this stuff front and back.
I combine mine with entry together with confined fleet entry permit. Is that acceptable?
That's fine. That works because you're going into a confined space. That works. And there's no one set bin entry format. So there's several examples out on the web. So search for those. Great, thank you. I'll be around for a little while, and I'd love to visit with you and hear your war stories, too. So, thank you.